So our next topic for functions is determining inverse functions. So not all the time, but sometimes whenever we have a function and we find its inverse, the inverse is also a function. And we did a few questions before, and we've looked at examples before where I showed you examples of things that the inverse is not a function. So to find the inverse of any function, we are switching the independent and dependent variables. We're switching the position of the x's and the y's. And the way that we write that down is like this, f to the power of negative 1. So let's do an example here. The rule of the function f is y is equal to 2x minus 9. And I'm asking you here to find the rule of the inverse function. Okay, that's what that means. When you see find f to the power of negative 1, it means find the rule of the inverse function. So I'm going to switch the independent and the dependent variables. And this is what it's going to look like. So here I have y. That's going to be switched to x. Here I have x. It's going to be switched to y. And the way that's written right now is actually not our standard form. We want to be able to move things around so that y is on the left and everything else is on the right. So I'm going to do a little bit of rearranging here. Divide everything by a 2. And I'm actually going to rearrange so I have y on the left is equal to 1 over 2x plus 9 over 2. Okay, that's our rule. That's the rule for our inverse function. And it doesn't matter what type of function. This was an example of a linear function. It gives us a linear function as the inverse as well, and that will always work. But there's a whole bunch of different kind of functions, different families of functions, and we can always try to find our inverse by doing this.